All right. Thank you for having me. My name is Doug Hanson. I work for the Geological Survey for a little over 30 years now. And this is a presentation on the critical minerals of Arkansas. Okay, the first figure here is physiographic provinces of the state, Ozark Plateaus, the Arkansas Valley, the Ouachita Mountains, the Mississippi River alluvial plain, and the West Gulf Coast plain. This is a generalized geologic map of the state, and you can see where some of our critical minerals are occurring. We have in the north and east half of the Ozark Plateaus in the north part of the state. We have occurrences of the critical minerals. And then in the central Arkansas and western Ouachita Mountain area, we have a large concentration of our critical minerals occurring there. The first critical mineral we'll talk about is aluminum or bauxite. Where we have produced in the past was Pulaski and Saline County. Some of the associated minerals with these deposits are titanium, gallium, niobium, and the rare earths. Now, bauxite was first discovered in 1888. It was mined for aluminum production from 1898 to 1990. And this area in Pulaski and Saline counties is roughly 275 square miles in the Gulf Coast plain. Total production during this time was more than 70 million long tons from tertiary age deposits. The highest yearly production, 1944, over 6 million long tons. The source of the bauxite, it's a byproduct of a mid-Cretaceous batholith composed mostly of methylene cyanide that is either close to or near the surface here in central Arkansas. The principal minerals, gibbsite, boehmite, and phosphor. There are common aluminum-bearing minerals. The type of deposit, it's residual, colluvial, stratified, and conglomeratic. The associated minerals with the bauxite were gallium, titanium, and niobium. The gallium was produced from 1947 to 1983. It's a byproduct of the bauxite processing. Now, the average content was 0.0086% or 2.75 ounces per ton. The niobium, there's been no production of niobium. U.S. Bureau of Mines estimated in 1954 that 1.5 million pounds of niobium metal was present in the bauxite deposits. Titanium has not been produced from bauxite mining either. Antimony, we find antimony in the southwest part of the state. This is still Ouachita Mountains in northern part of Clark, Pike, and Sevier County. The mining district was primarily in Sevier County. The minerals we have with these deposits are copper, iron, zinc, cinnabar, and bismuth. Now, the mining was in 1873 to 1947. Production through 47 was 5,390 tons. U.S. Bureau of Mines estimates 500 tons of concentrate from 700 or 27 mine sites that are now abandoned. The two principal antimony minerals are stibnite and stibiconite, and it's associated with copper, iron, zinc, bismuth, and cinnabar. Okay, lithium. We have two principal areas where lithium occurs. Talk about both of these. The Washita's, you find it in Polk, Montgomery, Saline, Perry, and Pulaski counties. In South Arkansas and the Gulf Coastal Plain, it occurs in Millard, Union, Columbia, Lafayette, Nevada, Washita, Calhoun, Bradley, and Ashley counties. Now, the primary areas where we have the occurrence is probably in Lafayette, Columbia, and Union counties. Okay, the occurrence in South Arkansas and the Gulf Coastal Plain, it is in oil field brines produced from the Smackover Formation. The Smackover is Jurassic in age, and from previous sampling, we know there's at least 445 million parts per million lithium in these brines. Now, the bromine brine is the primary product, and Arkansas is a leading producer of bromine in the nation. Reserve figures for the lithium keep changing. I've seen from 500,000 tons to now close to 5 million tons lithium in reserve. Now, as the business advances and more data becomes available, we might have better numbers there. We do know the USGS is planning to assess this resource in South Arkansas in the near future. An operational extraction pilot plant is now producing lithium chloride to the tune of 20 tons per year. A second similar extraction plant is being planned, and permits are being altered to include the product of lithium carbonate. Other sources or other occurrences of the lithium in Arkansas occur in Polk and Montgomery counties, hydrothermal veins throughout the Washita Mountain region, alkaline igneous complexes we have in central Arkansas. The lithium occurring in Polk and Montgomery counties is associated with manganese oxides deposits occurring there. Primary lithium mineral occurring in hydrothermal quartz veins are cookite, kyanolite, and lithophorite. Okay, manganese. Manganese is found in the Ozarks and in the Washita Mountain provinces. In North Arkansas, it's found in what we call the Batesville Manganese District, which you find in southeastern Stone, southern and northern Independence County. In the Washitas, it occurs in Pulaski, Saline, Garland County, Hot Spring County, Montgomery County, Polk County. Now, the primary mining area was in Polk and Montgomery counties. Associated minerals with these manganese deposits are rare earth elements, titanium, and cobalt. Most of the mining effort was centered in the Ozarks in the Batesville district. And about 98% of the manganese mined in the state came from this district. In this district, there's 4 types of deposits that have been classified. manganiferous clay, residual, and placer. And these are mostly from Ordovician to lower in age. Work in the Batesville district started in 1847 and was terminated in 1959. Production in 1958 was 150, greater than 150 tons of milling grade ore. USGS figures for the district, there was 200 million tons of ore at 4 to 9% manganese. In the Ouachitas, you have the biggest occurrence in Polk and Montgomery counties. Here, the manganese oxide occur in the Devonian to the early Mississippian, Arkansas novaculite and Stanley shale formations. Now here it occurs in pockets and veins from ½ inch to 10 inches. In the novaculite, it occurred as a cementing agent in angular novaculite talus floats. Principal minerals, solomolene, pyrolusite, manganite, and wad, associated with clay and iron oxides. Critical minerals included rare earths, lithium, and the cobalt. Okay, now cobalt is associated with the manganese-bearing sites in Polk and Montgomery counties, also in the manganese district at Batesville. In 1983, analysis of 140 samples collected in the Ouachita Mountains by the U.S. Bureau of Mines determined cobalt ranges from 0.5 or 0.05 to 1.2%, and that's combined copper, lithium, and nickel, and that was in 40% of the deposit samples. Cobalt is concentrated in lithophorite. Resource estimates 1 million to 6.4 million tons. Associated minerals, manganese, lithium, nickel, and copper. Okay, rare earth elements we find in the associated manganese district in Batesville, in Van Buren and Searcy counties, in the Ozarks and North Arkansas. In the Washington, find it in Pulaski, Saline, Garland, and Hot Spring counties. And most of this is associated with some of the igneous complexes we have in Central Arkansas. And then in Cleveland County, which is a pluton occurring there. Associated minerals, phosphate, phosphorites. Okay, here in the state, the rare earths occur in two rock types, igneous and sedimentary. On the igneous side of things, we have alkali igneous complexes occurring in Hot Spring, Garland, Pulaski, Saline, and Cleveland counties. The analysis from the Hot Spring County occurrence at Magnet Cove shows up to 4.3% combined rare earth elements. Selected samples of bastonosite collected by the Arkansas Geological from Magnet Cove contained over 30% combined lanthanides. Sedimentary deposits where rare earths occur, Batesville Manganese District, and in Searcy and Van Buren counties. The phosphorite from this district has an average rare earth content of 1692.2 parts per million. Mining of the phosphate-rich rock in Van Buren took place in 1963 for a very short time. They were mining it for the phosphate rock, um, but only a few tons were produced. Now we have a full set of core data and drilling map at those deposits that are available. No, out of these two counties, no mining in place in the phosphate deposit in Searcy County. Strontium, we have strontium in the form of celestite and strontiumite showing up in Howard and Pike and Sevier counties. Now these deposits are in the lower Cretaceous Trinity group, come out of the Queen limestone member there. The Celestine has a 50.4% strontium content, while the strontiumite is 70.1%. In the state, it was first reported by the U.S. Geological Survey in 1901. 1,500 pounds of Celestine was collected by the W.F. Heights Company. I don't know what happened to any analysis. In 42 and 43, there was an exploration project where 750 holes were drilled over a 30 square mile area in Howard County. From that study, I mined 90 tons of ore from open pit, and it was sent to Texas for processing. Since then, we've had no further mining of the celestite or celestine in the state. Titanium, we have titanium in Yale, Pulaski, Saline, Hot Spring, Garland, and Howard counties. The most noted are going to be in Hot Springs and Garland County. Okay, in Hot Spring and Garland County, we have igneous, alkali igneous intrusions that are bringing rutile, brookite, and perovskite in deposits of vein deposits in the igneous rock from quartz brookite veins in Arkansas and the vaculite in the metamorphosed zone of the intrusion. Perovskite is associated with the carbonate-rich bodies, piercing magnet cove. Rutile was mined from magnet cove from 1932 to 44, and they produced about 400 tons of concentrate. U.S. Bureau of Mines suggests that there's over 8 million tons of titanium-bearing material, 4 to 8% TiO2 in magnet cove. In Garland County, values were noted during the mining of vanadium ore at Potash Sulphur Springs, but it was never recovered there. Additional placer deposits we have noted in Hot Spring County and Howard County and along the Arkansas River. In southern Howard County, an investigation by the survey estimated that there was a little over 100,000 tons of ilmenite mineral concentrate within 50 feet of the surface. During 1939 to 1940, along the Arkansas River in Yale County, 12.8 tons of ilmenite was produced from sands along the river. Principal or associated mineral we have is niobium, which the niobium occurs in the Gulf Coastal Plain and the Ouachita Mountains. And it's associated with these Cretaceous alkali igneous complexes in their contact metamorphism. The in Ouachita Mountains, we got the Potash Sulphur Springs in Garland County, which the Magnet Cove there in Hot Spring County. It's got a substantial deposits of titanium-bearing minerals, brookite and perovskite and rutile. The perovskite may contain up to 9% niobium. Crystals of the rutile and brookite like 2 to 5% niobium. Potash Sulphur Springs, the niobium was present in the mineral pyrochlore. U.S. Bureau of Mines estimates 12 million pounds of niobium contained in the rutile deposits there at Magnet Cove. In the Gulf Coastal Plain, niobium occurs in Pulaski and Saline counties, and it's associated with the bauxite deposits. Arkansas bauxite deposits are reported to contain niobium values of 0.02 to 0.1%, and average 0.05% niobium. In 1954, the U.S. Bureau of Mines estimated in the bauxite and waste finds it contained 12 million pounds of the niobium metal. Associated critical minerals we have that with the niobium are the rare earths, the lithium, titanium, vanadium, uranium, thorium. Okay, barite, our only non-critical mineral, was produced in Hot Spring County, Polk, and Montgomery County. County has deposits in lower Cretaceous units, while the rest of the deposits are in the Ouachita Mountains. Okay, in the Ouachita Mountains, we're talking Hot Spring County, Montgomery County, Polk County. The barite in Montgomery County was noted in 1888, and then in near Magnet Cove in 1900. Mining began in 1939 near Magnet Cove. During 1944 through 66, the Chamberlain Creek deposit at Magnet Cove was the nation's leading producer of barite from stratiform deposits. Total production, 9 million tons, and that's from 1939 to 1983, with 8 million tons of that coming from the Chamberlain Creek deposit. The reserves are estimated to be in millions of tons. Deposits occurring in the Mississippi and Stanley Formation, with minor occurrences in the novaculite and lower Cretaceous terrain deposits. In the 70s and 80s, barite was mined from the Fancy Hill District, Montgomery County, and from the Pigeon Roost deposit northeast Glenwood in Montgomery County. Now, the Arkansas Surveyor has all the mine plans for Milchem Corp's Fancy Hill deposits in the Montgomery County. We have over 165 maps and figures with core analysis. Now, the reason this material is Milchem had set up a processing plant, and when they were set to open the plant, international markets came online, rendering deposits here in Arkansas non-economic, but we still have them. Okay, our igneous complexes. We have Potash Sulphur Springs, Magnet Cove igneous complexes. At Potash Sulphur Springs, we have titanium, lithium, niobium, vanadium, and uranium. At Magnet Cove, we have titanium, lithium, niobium, rare earth elements, vanadium, and thorium. Okay, during the 1950s, while searching for radioactive material, vanadium was discovered in economic quantities at potash sulfur springs igneous complexes and at Magnet Cove igneous complex. 1962, Union Carbide delineated several grade deposits in highly altered contact metamorphic sedimentary rocks surrounding potash sulfur springs. And at the Christie deposit at the adjacent Magnet Cove igneous complex. And these were all found in recrystallized in Arkansas, altered Arkansas in the backlite. Principal minerals, vanadiferous goethite and some minor vanadium bearing brookite. Approximately 4.8 million tons of 1.2% V2O5 has been processed from these deposits. Last production was in 1990. But we have delineated T deposit and the Spalding deposit at Potash Sulfur Springs, and it contains ore grade rock, and it has not been mined to date. Minerals associated here with the vanadium are titanium, niobium, molybdenum with a lesser amount of tantalum, uranium, complex rare earth oxides, and fluorine. Okay, the thorium, it was during the 50s when it was discovered here in Hot Springs and Saline counties. In Saline County, it was present in quartz feldspar veins, and it analyzed out as 0.019% uranium.
No, I went to Giant and had them look at
0.15% thorium. And there's been no mining of these elements in the state. Uranium, Marion, Garland, and Pike counties. They're associated with the igneous intrusions. Soil samples and assayed were 0.4% uranium at the Magnet Cove site. The Rankin Prospect, Pike County, found radioactive carbon fragments in Cretaceous Trinity rock. The highest assay value was 0.24% uranium. The Bear Hill Prospect in Marion County, this was uranium oxide from black shales, was 2%. And there's been no mining in the state for these. Okay, these are references on these critical minerals here in the state. Okay, the recent involvement by the Geological Survey. Currently, we're have an Earth MRI and state mapping project and sampling for rare earths in the Batesville Manganese district in the upper 4 division to the lower Mississippi and age units. The USGS is planning to obtain geophysical data in part of the state this winter. And it could include the entire Arkoma Basin. And then we have a geochemical study sampling Devonian, Pennsylvanian, Cretaceous, and tertiary age units for the rare earth elements potential. a publication we just came out with. It's miscellaneous publication 25, critical minerals of Arkansas, and that would be available on our website. And here, if you need to get in contact with us, you can email us, give us a call. We'll try to answer your questions. Thank you.